episode 5. Here we go. So we've got this nice menu bar right here, and now what we want to do is actually start talking to the smart contract. So how do we do that? Well, let me go ahead and pull up smart contract wETH. So we've got this wrapped Ether token tracker. Now we are working on the Kovan blockchain. So Kovan wETH. If we look at the OX project, Kovan, deploy contract addresses. This is the Kovan address for the wETher, the Quether, Kovan wETher. It's a lot of Ether in here. That's 143,000 Ether. Good Lord. That's a lot of Ether. Anyways, the code is public. So what we do is we Control C, and I believe we go to remix, and we go, okay, I want to build a wETH.sol. So copy, you create a Solidity file on remix, and then you copy everything over. Look at it. Good God. Okay. Now let's take a look. Source file requires different compiler version. Looks like this is a 4.18, so you go to the select new compiler version and you pick 4.18. Pretty simple. Now, from here, what we want is the ABI. The ABI is the holy grail of talking to the Ethereum blockchain from JavaScript. I don't know what form it just copied it to my clipboard, but let's find out. And let's do this in home. I mean, we're going to do everything right on the home page, right? Just nothing complex. Okay, so this is what we get when it gives us this thing in the clipboard. It looks really quite bad, I gotta be honest. It could be a lot more condensed, and you don't need this whole thing, but what we will do is make a global constant for the component, I guess a local component, a local variable. We'll call this wETH, and then we'll go ahead and copy and paste this ABI. wETH underscore ABI, wETH AB. And then we will use this let's see what we've got. What kind of variables? We got the balance, we got our balance. And we've got two functions which we can access. One is the deposit, the other is the withdraw. Approve, you got to approve it, of course. Transfer from. Okay. So ultimately, we want to be able to do two things. We want to be able to deposit Ether into this contract, and in return, they increase our wETH right here. Balance of whoever called it or whoever made this deposit goes up by whatever the value of their deposit was. And then when we want to withdraw, it takes away. You see it says, all right, make sure they have more than enough that they're withdrawing. Subtract that amount from their balance. Transfer any of the Ethereum held in escrow in that contract back to the caller, to the person who initially originated the call, and fire a withdrawal event. No, we don't care about events right now. We're not too worried about events, but we do want to be able to deposit and withdraw, and we would like to be able to dynamically read what the balance of wETH is, our personal wETH balance. I'm really starting to like this wETH business. Now, one of the things that we need to be understanding about is that values on the blockchain change. They may be one, you know, if I have 300 Ether in my wallet and I convert all of it to wETH, it may be the case that I have 300 wETH and 0 Ether now. And that needs to be displayed on the front end. That needs to be displayed in a dynamic fashion. So one of the things that we're going to do to begin with, and we may not even touch this contract. No, we will. Yeah, we're going to get a dynamic Ether and a dynamic wEther balance going. So let's go ahead and do that first. There's a thing called component will mount, and this fires every time a component mounts. So what this means is component mounts, we're going to say we want to, and I can make like little notes right here, we want to make a 1 second ping on ETH balance, assuming Kovan. And I can make another constant variable called and all this means is it's the wrapped Ethereum for the Kovan blockchain, that address, and we're gonna go from here. We're gonna go into, we're gonna have three things. We're gonna have component will mount, component will unmount, and we're gonna have update balance. And I know this looks like incredibly weird syntax, but let me just think through this first. So when the component mounts, we want to make sure that the user is on the Kovan blockchain. This is something that we can change later to say is the user on the Ethereum, the main Ethereum blockchain, right? And the way we do that, and you can refer to the GitHub API. It's in fact, we are going to refer to the GitHub API. We're going to go track that down right now. GitHub Web3 JavaScript. Yep. And 42. Why am I searching 42? Wow, okay. It's not what I wanted. I want to figure out what blockchain we're on. Web3.current provider. And in order to do that, there's a specific code, there's a specific value that you have to reference. And I apologize because I don't have that on hand at the moment. But I have another project that does have it, so we're just going to go pull it up from there. Let's go ahead and pull this up in wETH, or so I call it. web3.currentprovider.publicconfig_store._state.network_version equals 1, which means the main Ethereum network. You can see why I needed to go look this up, because this is bonkers, and in fact uses a very similar I can actually show you what it does. Oh, see what interesting. All right, we'll go ahead and delete that second part. Now, what's going to happen? I'll show you. Basically, when the component mounts, you set a specific value for an interval, just like we have here. And you say in our state, you say balance check, set that to some empty string, right? And then when the component mounts, you set that balance check to an interval, and you say this dot update balance. And we want to do that like every second, right? So this is milliseconds. So we do this every 1,000 milliseconds. And then what we do is we check for the web3.currentprovider.public-config store is equal to 42. That is the tongue-in-cheek number which identifies the Kovan blockchain. And then from here, we're using an interesting syntax, which I kind of just want to delete this and sort of break it down, but let me throw this down here and explain the syntax. So you're accessing that Web3 variable and you're saying we want to create a object that represents something using the ABI that we have. So remember how we have that wETH ABI? And this is our language. This is how we're going to talk to this smart contract. And then we need a specific address, you know, this wETH add to talk to. And then from there, we say, okay, so we have a language to talk to this smart contract, the interface, we have an interface for it. We have the address of the specific smart contract, the unique address. And from here, we're just saying we want to call a specific function. So what function could we call? Probably the balance of. And I know there's a lot of balance ofs, but let me go up and show that. So you can kind of see how each one of these is a specific part of the smart contract that we're able to talk to thanks to the ABI. And this particular one is saying, you know, if you want to figure out what the balance of, if you want to call it because it's a function, and we can see that it's a type function. I guess I'll just run through each one. Constant means whether you're able to get a specific value back or not. If you don't get a value back, it's not constant. Inputs are what you need to put into it. So we need to put in an address, which is done in the very first. So let's say we want to get the balance of account 0. That's actually a way to reference our own MetaMask account. And then from there, the only other thing that is really of importance is what you're going to get out of it. You're going to get a uint256 variable of no particular name. It's just a single return value. If you have multiple outputs, you would get different names on it so you could reference it. Payable would mean if you're able to pay in Ether. Now, this is important to note because there is actually a function where payable is true. And that is the deposit function. And it's true because remember, if we want to take our Ether, send it to a smart contract, and get this wETH token back, we need to call a function that's payable so that we can send Ether to it. Now, if it doesn't have that payable modifier, Solidity won't even allow you to send Ether to the smart contract. So having that true is important. I think in state mutability, the view means it's payable if you're able to pay, non-payable if you are just making some state change. If you don't make any state change, as in update the value of a balance or something like that, then it's view. That's why balance of is view, because you're not changing the state. You're just saying, hey, smart contract, how much do I have? You know, and then it gives you that information back. Then there's a second parameter and a third parameter. The second parameter is a JSON structure, just curly brackets, and it's saying from our account. We are calling this from our account, because how does the smart contract know who's calling it or who's accessing this data, especially when the smart contract references message.sender. And if we have to authenticate, like if we need to use a private key to create a function call or something like that, then it needs to know what account is calling the smart contract. Then the third parameter is a callback. So function E for error, R for result. If there is no error, then all we're going to do is update the wETH balance from whatever it is to, I need an if in front of that, and we're updating balance wETH to result.c0, and I will explain that in a second here by consoling.log r our result to show you what the data structure is that we get back from the smart contract and why we have to access this C variable, which is an array, and we're accessing the first element of the array. And we need to bind this callback function to this, because, and now you see it looks exactly like these other ones, but now you see that why we have this set up here. And we bind it to this because this dot set state is referencing state here. And the scope of the callback is restricted, so you need to expose or expand the scope of the this small tidbit of code right there. So we're going to do one other thing. We're going to get our own Ether balance. And no, we're not going to get our wEther. We're going to get our Ether. I'll show you exactly what it is we're doing. I'm just going to copy it over. web3.eth.getBalance from web3.eth.coinbase, which is another way of saying web3.eth.account0. And yeah, that was pretty good. Basically, this is getting our current balance of Ether. And, we're going to want to know what our balance of Ether versus wEther is at any given time, seeing as our whole application is built on converting from Ether to wEther and back. Now, this is very... Wow, I kind of want to add this in. All this is doing is just saying fix it to two variables and put a comma on it, to locale string. So let's go ahead and excuse me, do one last thing. When our component's going to unmount, we do want to clear this interval, so we access the, you know what, let's call ETH. We do want to clear the interval, so we say equals this dot state. We are localizing the balance check from state into this component will unmount function, and then we go ahead and call the clear interval function down on the balance check. And that is going to clear this from bump, 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 bump every second pinging the blockchain. This is a little bit of optimization when this component unmounts, because you don't want it to continue to call. Say someone's on the home page, right? And then they go to oh, and I told you I was going to show you. So you see here, every second when we ping the smart contract and we get a data structure back, the value is held within the 0 right there. Now, let me just show you what is going to, we don't need to console log that every time. Let me show you what's going to happen to our front end interface. So we've got the wETH and the ETH. You throw that into a const within the render function, just like we're doing in the component will unmount function. And we're going to reference those as such. So you can see that it is pulling my Ether balance here on the front end, 299.41. If I were to say, oh, and when I change accounts, it tracks that. So that's really nice, that because it's pinging the blockchain every second. And notice that when I switch accounts, it says, well, how much does this account have? Boom, oh, it has this much now. So it'll do that too for the wETH balance. And if I send to my other account a little bit, 1 ETH, then as soon as this confirms, we're gonna have 298.4116, and on the blockchain down here, on our web app down here, 298.4114, and we got 298.41. So we have a number on our front end interface saying, well, how much Ether does this guy have? How much Ether does this guy have? And as soon as we create the buttons for actually interacting with our wETH to Ether, or our wrapped Ether smart contract, then we can begin making function calls to it and actually watching dynamically our Ether and our wETH balances change as we convert back and forth.